The Cobra Extinguishing Concept, CEC, is the safe and most efficient way to take control and minimize risks at compartment firefighting. The method is based upon 3 combined tactical parts. Scan the outside of the building with thermal imaging camera. Rapidly cool down the hot fire gases with the Cobra, and ventilate with PPV. Altogether, this creates tactical advantages and much safer environment for fire personnel entering the building. The efficiency of the Cobra is superior to any other application of water due to the very high pressure, which creates a very fine water mist ejected at very high speed. The system delivers 60 liters per minute, no water damages, and safe operations for the firefighter. Cobra is easily operated by one person and can be fitted to any kind of fire vehicles. By its unique capability to quickly pierce through any type of material and fight an inside fire from an external and safe position, the Cobra dramatically increases the firefighter's safety and efficiency. SP Technical Research Institute of Sweden has done considerable research on the Cobra. Most significantly, the drops are extremely small compared to any other systems in the marketplace. This means that the total surface area is very high from the Cobra, and hence the efficiency of the cooling effect. When comparing the Cobra drops to drops from high pressure nozzles or fog nails, the distribution of droplets is 0.1 mm for the Cobra and almost 1 mm for the other systems. The water droplet size is one of 3 critical components of the efficiency and is generated by the very high pressure. This illustration demonstrates the relative difference between the Cobra water mist and the relatively big drops generated by fog nails or high pressure nozzles. The 2 additional components are the speed of the water jet and the water volume, which determine the maximum suppression capacity. As a comparison, the total surface area of the water from a standard 8-bar firefighting nozzle will cover a normal soccer goal, while the same amount of water from a so-called high-pressure nozzle of 40 bars will produce a total of half the penalty area. This includes the fog nails that are being used in some markets. Note that if the surface area is small and the droplets are big, most water applied will have no effect on suppressing the fire, but instead only create water and environmental damages. Big drops fall to the floor 10 times faster and will not evaporate, while the Cobra water mist hangs in the air until evaporated in the hot gas. Ultra-high pressure systems going up to 100 bars produce smaller droplets, but still the surface will only cover a third of a soccer field with the same amount of water. The Cobra, as a comparison, will generate a total surface area of the whole soccer field. The following graph displays the heat absorption comparison between the Cobra and other systems. The graph demonstrates that the Cobra efficiency is 5 times higher than the other tested systems, only due to the droplet size. When considering the much higher speed, the effect is several times higher. The heat absorption efficiency confirms the common empirical view that only 5 to 10% of the water of conventional firefighting is effective, while 90 to 95% of the water from the Cobra actually suppresses the fire. As a final demonstration, the pressure of 300 bars also generate a very high velocity of the jet. The research demonstrate that the Cobra jet has a speed of 200 meters per second at the nozzle. But even after 15 meters, the Cobra jet will have a speed of 5 meters per second. This means that the reach of the jet and suppression is very long, up to 60 meters in compartments according to experienced incident commanders. But also that the Cobra jet will generate turbulence, hence reaching all the hot gases in the compartment. As a comparison, 40 bar systems will only have a droplet speed of about 1 meters per second, 2 meters from the nozzle.
The future firefighting project can be broken down into 3 elements. Firstly, the incident commander will use thermal imaging to scan the building to identify the areas of high temperature. The incident commander will then formulate a plan and, when appropriate, will instigate the second element. The incident commander will instruct the ultra-high pressure lance operator to deploy the lance. The temperature in the compartment will start to reduce rapidly. As you can see, the use of the ultra-high pressure lance has reduced the temperatures in the room from 700 degrees centigrade to 85 degrees centigrade in less than 45 seconds. The incident commander will then utilise the third element of the process by incorporating tactical ventilation to remove all the fire gases from the compartment.
This example for good use in the Cobra system is an industrial hotel. The fire has started in several cars standing from the outside of the building, and now very rapidly the fire is spreading even to the inside. We put in the Cobra unit to cool down and prevent to spreading the fire to the side room of this industrial hotel. And during this action with the Cobra, we even combined with the PPV fan, and we pressurized the side room of the building, and we use up to, I think it was 11 units of PPV fans. And these combined use of the Cobra system and PPV fans save up to nearly 80% of this big building. It was 10,000 square meter size, and we save 80% of that, and the saving cost in these fire was €10 million.